Alrighty, good morning or good afternoon, ladies and gentlemen. Happy Wednesday. Today I'm going to show you how we're going to use our clinometer. This video is going to be a bit different. So I'm actually going to go on a walking tour and I'll show you how we can use our clinometer and part of our assignment. So part of our assignment is going to be to measure the height of 3 tall objects that we can't measure ourselves, like a tree or a building. And I'll show you how we can do both of those. A couple things you'll need before we go on an adventure is you're going to need your built clinometer. So if you don't have that, you need to go to our previous video and watch that. Make your own. As part of the assignment, I'll have you post a picture of yourself with a clinometer so I know that you did this properly. As well, you're going to need some sort of measuring device. So for myself, I've got one of these fancy track measures. Chances are you probably don't have one, so a tape measure is fine. Or if worse comes to worse, you can always use your feet. So when you use this, you can always pace off some of the steps yourself. Just keep in mind that when you do it, that you are measuring the height of the building in the same unit. So if you're measuring it in inches, you're gonna be measuring it in inches. If you measure it in paces, like say you don't have a tape measure of any kind, you're gonna be using your paces as the height of the building. So we're gonna jump outside. I'll show you exactly what we're gonna be doing and I'll show you the rest of the assignment and kind of go through why this works. All right, so here I am outside the school. I'm walking through the parking lot. The height of the building that I'm choosing to look at is going to be the 600 wing from the parking lot side. So what we are doing is we're constructing a right angle triangle out of a couple of things. The first thing is going to be the ground. Then forming a right angle with that is the height of our building or object like a tree. And then our third line, our hypotenuse, will be our eye line. So we're not making an actual triangle, but constructing those, you will get a right angle triangle every time. So we're gonna need a couple things for that to work. We're gonna need, first off, we're gonna wanna be on level ground. So if you're on a hill, this isn't gonna work very well for you because we want that angle of the ground to the building to be as close to 90 degrees as possible. Additionally, you're going to want to be dressed properly for outside because it is starting to get a little cold, and you're going to want to look for a nice sunny day to do this because it's not fun to do it in the rain. Additionally, you also want to make sure you're in somewhere safe so that you're not running into people or cars or traffic in order to get this done. Now, one of the things I'll point out is that this method of finding angles was used for prospecting, like using it to look at heights and angles of buildings and construction. But where this was often used the most was in seafaring. So if you're on the ocean, there's a tool called a sextant. And what a sextant is used for is for looking at inclination from the horizon and being able to combine that with celestial things like stars or the sun or the moon in order to figure out where you were and to navigate properly. Okay, so here we are. I'm going to measure the height of our 600 wing here. So I'm going to need to give myself some space. So a couple of things. I have a nice long tape measure, and that'll help me get far enough away from the building to be able to measure my angle nicely. If you're not, then I can show you what you can do. All right, so if we're wanting to measure, let's say we don't have access to a tape measure, what we want to use is our feet. So I can go 1 foot. Notice how I'm up against the edge of the building, and I'm gonna go 2 feet, and then I can go 3, 4, 5, 6, 7. I'm gonna count my steps, 9, 10, 11, 12. And I want to get a far enough distance away that I'm able to measure the angle accurately. So I'm at 15, 16, 17, 18, 19, 20. And I'm gonna keep going until I am a decent chunk away from the building. So at this distance, it'll still give me a pretty steep angle looking up, but it should work. In any case, I'm going to measure mine out so I can actually show you on the computer the actual numbers. Alright, so currently I have my tape measure set up. You can see it going to the building, and I try to stick as close to a straight line as possible, so you want to measure straight out from the building. And if I bring it down, I can see that it comes up to 53 feet. So I'm going to be standing at 53 feet when I make my measurement. So keep that in mind as our first step. All right, so now I've got my clinometer. If I aim it this way, I have my building. So what my goal is, oops, still getting used to this. So what I'm going to do is I'm going to look through the clinometer at the top edge of the building, and you'll see as I look up, once I find it, I want to carefully with my thumb hold the string. That way, when I pull back, I can find the angle measured. And I'm going to be reading the number off, and I see if I bring it here, we're right in the realm, sorry that's backwards, of 25 degrees. So the key bits of information that I need to remember for this is when I'm 3 feet away, I'm measuring an angle of 25 degrees from horizontal going up. So next we're going to meet back in the class, and I'm going to show you what we can do with these numbers to calculate the height of the building. Alrighty, so we're back here in class, and I'll show you how to go through these problems. So I've quickly drawn up, this is our 600 wing building, this here is Mr. S. I've gone 53 feet, and I'm looking up at the top edge of the building. So what I want to set up, notice how here I have a right angle. So what I basically have is, if you remember, I was 53 feet away, and the angle I measured was 25 degrees. So technically, I'll just draw it below so it's a little bit more clear to see. I have a 23 degree angle, I have 53 feet here, and I'm looking for the height here. And this is my right angle. So this is now a very, very, very simple problem. So I can look across, the height is now my opposite, and this is my adjacent side. So to solve for this, I'm looking at my SOHCAHTOA, and I see I have opposite and adjacent, so I want to use tan. So going back here, I can plug in, I have tan of theta is equal to opposite over adjacent. So I have tan of 25 degrees, so I put 23 here, I'm not sure why, equals height divided by 53. So then to find the height, I multiply up, so 53 feet times the tan of 25 degrees should give me the height of the building. So plugging this in, tan of 25 times 53 gives me a height of 24 feet high. Now, a couple things. This currently is not our proper triangle. If I take a look, where I measured from wasn't from the ground, it was from my eyeballs. So my actual triangle should be like this. So when I measured and I got my 24 feet, that was what I was measuring, was from my eye height to the top of the building. Now, the further away you get, the more this will shrink. But to help this out, what can we do for here? Our eye height is pretty close to our total height, so I can add my own height. So I'm 6'3", so that would be, I'm gonna round off to 6 feet because my eyeballs are not on the top of my head. So roughly 6 feet from feet to eyeballs. So total height is equal to 24.71 plus 6 feet equals 30.71 feet. All right, and that's basically how we do it. So real quick, in a couple seconds with one easy measurement, I was able to estimate the height of our 600 wing building from the parking lot by the basketball courts. Now, a couple things. You want to look along the line that you measured. So what I mean by that is, say you have your building, and I'll draw this kind of sideways. So the 600 wing building looks kind of like this, and then there's a little fenced off area here. So if you remember from the video, my tape measure kind of came this way. I want to look directly above it. The reason being is if I look over here, I'm now including, if I was to draw a triangle, I could still make a right triangle, but I'm now going to be going a further distance. So this is farther than 53 feet. So I'm going to be making a different right angle triangle. So I want to keep where I'm looking in line with where I measured from. And another thing with that is measure in straight lines. Like I said before, look for flat ground. For example, do not, if you're measuring, say, a tree, you don't want to be at the bottom of a hill looking up at it, because if you measure just this distance, it's not going to be accurate. It's also going to give you the entire height from the elevation. So you want to ideally be at the same level as the thing you're looking at. So the ground here is pretty level. We're never going to get perfect, but we want this to be as close to a 90-degree angle as possible. And we want to measure in straight lines. So relatively, this is a pretty simple step. So step one, make sure you make a little diagram like this for yourself. Set up your triangle. So you're going to have two things that you measured. You're going to have a measured angle and a measured distance. And they're always going to be the same angle and the same distance, and you're always going to be solving sort of this design triangle, and you're solving for the height. So generally speaking, for this equation, you're going to always be using tan, but just keep that in mind. And keep in mind that you're wanting to make this as accurate as possible, so you want to make sure you look in the same direction you measured and you measure in straight lines. Okay. All right, so lastly, I'll go into what our assignment is. So you want to make 3 height estimations using this method of 3 different buildings or trees or objects. preferably ones that are very high that you can't accurately measure with, say, just a tape measure. So the school is a good place to start, but if you live in a large apartment building or you go downtown, any one of those buildings would also do, or you can find a large tree in a field. Keep in mind, you want to be safe, so you don't want to just be walking out into the road to measure this, and you don't want to be right up against the building, so you want to make sure you have room to move around. So what I need is, for the 3, I need, for just 1, a picture of you and your clinometer. So it could be a selfie, but basically I want you to show me what you have made. So I want you to be a picture of you with the clinometer you made. This was a work in progress. And secondly, so you just need 1 of those just to prove that you made it. Secondly, I want photos of all 3 things that you're measuring and then where they are. As well, I need your drawing, your height equations, and your measured angles and distance. Keep in mind, if you are measuring it in paces, so you're walking out, tell me that. And when you give the height of the building, don't say it's in feet, say it's in your steps or your paces. If you really want to go the extra mile, you can also measure your foot length, so you can measure how big your shoe is, and then from there, multiply that length by how many steps you had to take. But basically, I need 3 different buildings, pictures of the buildings, and where are they, or pictures of the objects and where are they, if you're doing trees, as well as setting up your triangle picture and the equation to figure out the height. So I want to see the actual height, and then finally, just a picture of yourself and the clinometer. So that's it. I'm gonna make sure you have the whole weekend to work on it and the rest of the week, and I'll probably make it due Monday or Tuesday, so we'll already be back in class. But this will be kind of the thing that wraps up our trig unit. So take care, stay safe, have a good one. Hope you enjoy this. It's a really interesting assignment that you can use trig in the real world. So as always, stay safe, have a good one. Bye.